Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to gravitation. Previously we discussed some basic concepts related to gravitational field and gravitational field intensity. In this video we are going to discuss another important topic, which is the concept of gravitational potential energy. Now just a quick review that we discussed that every mass, it modifies the space around it. Okay, so within that space, its gravitational effect, its gravitational pull can be experienced by another mass. When it enters the field, it experiences a gravitational attraction force. So this modified space is called as gravitational field, and it operates as per the basic law of gravitation, that every object, it attracts other object with a force called as gravitational force, and this force is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them, and this is the formula for the gravitational force. Now here the concept of gravitational potential energy, or the concept of energy, before going into that, let us just review the basic concepts related to work and energy. First is energy. Energy is the ability to do work, to perform some work, to cause change in the position of an object. Suppose we move an object from one point to another. Suppose we lifted an object and put it at some higher point, let's say on the table or anything like that. We are using energy to do some work, to cause displacement in an object. So energy is the ability to do work, the capacity to cause change in the position of an object, that is performing work. Work is the transfer of energy from one object to another through the application of force which causes a displacement. So we can sum it up as energy is the capacity to do work, work is the process of transfer of energy. Okay, so as per this, we have work is equal to the dot product of force and displacement vectors. Okay, let us say we change the position of an object from one point to another. There is displacement S, force F, both of them are vectors, so work is the dot product of that. Now how we can correlate all this with gravitational force and gravitational potential energy, okay, along with gravitational field. So we know that every object, it attracts other object with a gravitational force. So this force can cause displacement in the position of an object. So we can say that gravitational force can perform work by changing the position of an object upon which the gravitational force is acting. So gravitational energy or gravitational potential energy is the capacity or ability or potential to do work, to perform work, to cause change through gravitational force. Okay, it is the ability of gravitational force to do work. Okay, so when gravitational force acts on an object and it causes a certain displacement, that work done that is the product of gravitational force and the displacement, that is called as gravitational potential energy. That is in simple terms. Okay, so when two bodies are placed close to one another, they exert gravitational force, and when the position of either of the two bodies changes because of the acting gravitational force, there is work done either by the gravitational force or against the gravitational force. In either case, the position of the body, it changes, and as a result of this, work is done, and as a result of that, the gravitational potential energy changes. So in simple terms, gravitational potential energy is the capacity or potential or ability of gravitational force to do work, and this work can be done in the direction of gravitational force or in the opposite direction of gravitational force. So here I am not complicating things unnecessarily. I am just going where the position is changing or the displacement is happening in the direction of gravitational force, to keep it simple. Okay, so let us say we have this situation. We have a mass m, slightly larger size, so larger mass. It has its own gravitational field, the modified space around it. We have another mass, small m, okay, slightly smaller size. It is at a far away distance from this mass, this yellow mass, the largest size mass. So when the distance is, very far away, infinite distance away from, there is infinite gap separation between these two masses, the gravitational force exerted, the mutual gravitational force, it will obviously be this much, okay, gmm by infinite square, so it will be 0 because infinity in the denominator, it will be 0. So as a result of this, the mutual gravitational force is 0, so no work is done, and consequently the gravitational potential energy of this two mass system, it is 0 when the object is at far away distance, at infinite separation. Okay, this is called as the zero energy level. Okay, when either of the two objects, they're separated far away, infinite distance apart, the gravitational force is very small, negligible, or 0. Now let us say this object, it slowly starts entering the gravitational field and is within the gravitational field of this yellow mass. This white sphere is within the gravitational field of this yellow sphere. Now, taking this into consideration, keeping this in mind, let's say within the gravitational field, the separation between them, the yellow mass and the white mass, the yellow sphere and the white sphere, let's say the separation between them is x. Okay, so in this case, the gravitational force exerted, the mutual gravitational force, it is equal to F is equal to gmm by x square. So here, for keeping things simple, let's say this large size mass m, capital M, it exerts a gravitational force capital F towards it. This is the value of that gravitational force. Okay, this is the situation, and here remember that this mass A, which is at position A, point A, it is within the gravitational field of the yellow sphere, capital mass M. Okay, now let's say we change the position of this object, okay, and move it, that this object, small mass m, under the influence of this gravitational force, it moves a small distance dx, okay, small distance dx up to position B, point B, under the influence of the gravitational force which is exerted by this yellow mass. Now in this case, there will be a small amount of work done because position has changed, small displacement dx has happened, force is acting, so small amount of work will be done. Let's say that small amount of work dw be equal to force into displacement, so F dx. F is equal to gmm by x square. The gravitational force, the mutual gravitational force between these two mass system. So this dw, small amount of work done in causing a displacement of dx, small displacement dx in the direction of gravitational force, that is equal to gmm by x square dx. Okay, this. So the position of the body has changed from A to B. Okay, small distance dx. Let's say now the position is changed from B to P. B to P. Now the separation between the yellow mass and the white mass, it is R. Initially the separation was X. Now the separation is R. So here if we start from the beginning, initially the object was at infinity. Then it entered the gravitational field. It experienced a gravitational force. Then it changed position from A to B through a small displacement dx. The gravitational force is this much. Small amount of work dw in causing displacement dx, that is equal to this much. Now we moved the object from B to P. Okay, so this is the total displacement. Initially from infinity to A to B, and then B to P. So totally from infinity to point P. From x is equal to infinity, the separation distance x is equal to infinity, to the separation distance x is equal to R. Okay, this is the total journey of this white mass under the influence of gravitational force. So the total work done in moving this white mass, this white sphere from infinity to point P is given it is given by so it will be given by total work W is equal to dW from 0, lower limit 0 to W, and here from x is equal to infinity to x is equal to R, integration gmm by x square dx. So this dW is equal to actually f dx, but f is equal to gmm by x square, so we have directly substituted here. F is equal to g capital M small m by x square, so we have directly made the substitution here. Now capital G is constant, the two masses, they are constant, so they go outside the integration part. Now we have lower limit x is equal to infinity to upper limit x is equal to R, integration of x to the power minus 2 dx. So we get the integration g capital M small m minus 1 by x, upper limit R, lower limit infinity. X is equal to R, x is equal to infinity. Lower limit is infinity, upper limit is R, because the journey has happened from x is equal to infinity. Okay, this is x is equal to infinity, this point. At this point the separation distance is infinity, and at this point the separation distance is equal to R. Okay, here when the body is at point infinity, the separation distance is infinity, x is equal to infinity, the separation distance, and at this position point P, the separation distance is R. So this is the lower limit, this is the upper limit, infinity to point P, x is equal to infinity to x is equal to r. So when we perform this integration, we have minus gmm, we take the minus outside, so we have 1 by r minus 1 by infinity. 1 by infinity is equal to 0, so we have minus g capital M small m by r. So this work done by definition, this is the expression of the gravitational potential energy of this white mass, this small mass small m. Okay, so whenever we have any two body system, two object system, let's say we have two bodies, one is of mass capital M, one is of mass small m, their separation distance is r, the gravitational potential energy of this two body system is equal to minus g capital M small m by r. So the potential energy, it is directly proportional to the product of the two masses and inversely proportional to the reciprocal of the separation distance. And this negative sign, what does this negative sign indicate? It means that this potential energy is due to the gravitational attractive force, the gravitational force of attraction between the two bodies. The work is done by the gravitational force of attraction. The displacement has happened in the direction of the gravitational force. So energy is used up by the gravitational force to change the position of the object. So as a result, the gravitational potential energy is used up, it is expended, so it gets reduced by this much amount. And as the separation gap, it decreases, the gravitational potential energy keeps on reducing like that. Okay, so this is the concept, this is the meaning of the negative sign. Magnitude wise, it is simply g capital M small m by r. The negative sign says that the work is done by the gravitational force of attraction. So what is the definition of gravitational potential energy? The gravitational potential energy of any body, any object of a certain mass is the energy associated with its position in the gravitational field of another body. Yes, as the position changes, as the position r changes, the gravitational potential energy changes. Yes, and we can define it as the amount of work done in bringing a mass from infinity to a certain point, here in this case from infinity to point P, from separation gap x is equal to infinity to separation gap x is equal to r, from infinity to point P in the gravitational field. So here gravitational potential energy is associated with this mass small m. Okay, so the gravitational potential energy is measured by the amount of work done in bringing a body, an object, from infinity to a certain point, to a given point in the gravitational field of the other. This work done is by definition the gravitational potential energy from infinity to a certain point, the total work done. Okay, now let's say if we want to determine the change in potential energy, each position is associated with a certain potential energy. Let us say we have an object within the gravitational field of the other. We have an object of mass small m, the white sphere. It is at an initial position I. At that position, the separation distance is r1. So the gravitational potential energy associated with this initial position, it is equal to minus g capital M small m by r1. Then it moved to point F, the final point, under gravitational force. At the final point, the gravitational potential energy is minus G capital M small m by R2. At point F, the separation distance is R2 between mass capital M and small m. Initially it was R1, then it got reduced to R2. So the change in potential energy is final potential energy minus initial potential energy. So it will be equal to minus G capital M small m by R2 minus G capital M small m by R1. So minus minus will become plus. So we have it is equal to the change in potential energy, that is equal to minus G capital M small m by R2 plus G capital M small m by R1. Okay, minus minus, this becomes plus. So we can write it as taking G capital M small m common, 1 by R1 minus 1 by R2. This is the change in potential energy. Or R2 is the final point, R1 is the initial point. We can write it as, in terms of initial and final points, G capital M small m, 1 by the initial position minus 1 by the final position. Initial separation, final separation. Okay, this is expressed here. As the position changes from initial to final point F, the change in the potential energy is expressed as this. UF minus UI is equal to U2 minus UI. So we perform the same integration, we'll get the same result. Here instead, you directly use this formula. You find out the gravitational potential energy at position R1 minus GMM by R1, then at the final point minus GMM by R2, final minus initial, we get this. So this will get the same result, G capital M small m, 1 by R1 minus 1 by R2. In terms of initial and final position points, we have G capital M small m, 1 by Ri minus 1 by Rf, where Ri is the initial separation, okay, and Rf is the final separation. Okay, so this is the thing. This is the concept of gravitational potential energy. Okay, so summing it up, the gravitational potential energy is the total work done in bringing a mass m from infinite separation, from infinity to a certain point within the gravitational field of a certain mass. Okay, the total work done. And for any two objects with a certain separation distance, the gravitational potential energy is given by this, minus G capital M small m by R, where capital M and small m are the two masses, small r is the separation distance between them. The negative sign, it indicates that the work is done by the gravitational force. Okay, so this is the concept of gravitational potential energy. So here I request you to please watch all the videos in a systematic manner, starting from gravitation, then all the concepts serially, as I have posted videos. You can check the playlist, and in a systematic manner you go from one video to the other so that you can understand these concepts in a good way. Okay, don't skip any videos. So this is the concept of gravitational potential energy. Okay, so this is the thing. And here another important thing, the unit of gravitational potential energy, it is joules in SI units and erg in CGS unit. Okay, so this is the thing, gravitational potential energy.